Okay, good morning. I have a problem I'm hoping you can all help me with. I'm getting a new pool in my house. Problem is, I have to order fencing to go around the pool. And I don't know how much fencing to buy. Now it's going to be a circular pool, and I know that the pool is 12 feet in diameter, and I know there's going to be 3 feet between the pool and the fence on each side of the pool. And I have to figure out how much fencing I should buy. So here's what I've mapped out with regards to, see, there's my pool. See it? So how much fencing should I buy? Can you help me figure it out? Okay, you've all been given circles like this. And all like this. And I gave you all string and scissors and rulers. Can you each in your groups measure the diameter of your circles and the circumferences of your circles? And we're going to see if we can figure out a formula I can use so I can order the correct amount of fencing. Okay? Oh, John, what is it? Oh yeah, the string is hard to work with on your circle. I guess you have, what, a cup there? So here, I'm going to also hand out some tape and tape the end of your string to the edge so that could hold it in place for when you try to start wrapping the string around the diameter, around across the circumference of your cup. See? Okay. Then, with your markers that I gave you, mark where the two pieces of string come together, and that's your circumference. So once you mark it with your marker, then you can cut it with a scissor, and now the string is the exact measurement of the circumference of your circle. Okay? Okay, so let's all do that. Take a minute. Let me know if there's any questions. I'll walk around the class and see if there's anything I can do to help you. Okay. So everybody mark down in your groups, mark down the measurement of your string, which is now the exact measure of the circumference of your circle. Everybody, have you done that yet? Sally, you're all set with that? Okay, good. Now, with your rulers, measure the diameter of the circle that you have. Okay? With your ruler, measure the diameter of your circle. Okay? So now each group should make 3 columns on your paper. 1 column is for the circumference, 1 column is for the diameter, and the next column we'll talk about in a minute. Okay? Alright, so third column is going to be the circumference divided by the diameter, ratio of the circumference to the diameter. Okay. Scott, can you give me the measurement for your group? Okay, the circumference was 23 centimeters, 23.0, okay. And the diameter was 7.4. Okay, next. Stephen, Okay, your circumference, the circumference for your group was 27.5 and your diameter was 8.7. Okay. And Linda, okay, your circumference was 18.0 and your diameter was 5.7. Okay. So now let's see the ratio of these by dividing the circumference by the diameter. So for the first group, your ratio was 3.11. The next group, your ratio is 3.16. The third group was also 3.16. Okay. Next, let's add them up so we can get kind of an average for those three circles. Okay, so here I wrote them down also, and they added up to 68.5 for the circumference, 21.8 for the diameter, and the ratio is 3.14. Okay. Now, turns out we're not the first people ever to do this kind of little experiment with circles. Thousands of years ago, a mathematician named Archimedes was really the first to rigorously look at things like this. And he estimated what is now known as pi. And for years now, we know that pi is approximately 3.14. And actually, we usually stop pi at 3.14, but the decimal places go on forever. Okay, so now we know that the circumference equals what? If we found pi, we found our 3.14 by dividing the circumference by 2. We divided the circumference by the diameter. So what does that tell us about the circumference? The circumference equals what? Equals pi, and this is the symbol for pi, times the diameter. Okay, so that, now we know, in terms of pi, how to calculate the circumference of a circle if we have the diameter. So now, could you guys, in your groups, determine for me how much fencing I should order for my new pool? Now remember, the pool has a diameter of 12 feet. Then there's 3 feet on each side of the pool where we can walk around the pool and things like that. And then there's the fence. So what is the total diameter of the area of the circumference of the larger circle? Jessica, what? 15 feet? Can anybody help Jessica out? Yeah, Scott? Yeah, 18 feet. Right, because we have the 12 feet for the pool diameter, plus 3 feet on one side, and 3 feet on the other side. So that's a total of 12 plus 3 plus 3, so that's 18 feet. So Jessica, what's the diameter of the large circle then? In my original diagram? Right, 18 feet. Okay. So we know the diameter. And we know pi now is 3.14. Can you tell me what the circumferences of that large circle. And once we know that, then I know how much fencing to order. So it's what? 3.14 times 18. Stephen? Yes. 56.52 feet of fencing. I can't order a fractional foot of fencing, right? So how much fencing should I order? 56 feet? No. Right. Scott? Yes. 57 feet of fencing. Okay. So let's try one more example. I want to make sure you guys have this in case you have to install a pool. So let's say you have a larger pool and its diameter is, including the walkway on either side, is 24 feet. So what would it be? I need to work on that for a minute. Jessica, how many feet of fencing would you have to order for your larger pool of 24 feet in diameter? Right, the math would be 75 feet, 0.36. So how much feet of fencing? Right, 76 feet. Okay, excellent. Any other questions? Okay, thank you.